Assalamu alaikum everyone and welcome to Mathematics with Shahab Yaqub. So now where exactly are we? We are on the lecture number 25. That is lecture number 25 of Algebra. And this is sequences, number pattern, lecture number 2. It's part of Algebra, but at the same time, I am labeling it separately. So now let's first go over what did we discuss last time. So last time was all about exploration. That is, what was the syllabus of number pattern? And then we talked about sequences in which there is addition of a constant value. That constant value could be an integer, it could be a fraction, it could be a decimal, it could be positive, it could be negative. Addition of +2, addition of -10, addition of +3, addition of 5, and so on. This is known as an arithmetic sequence. A is denoted as the first term, D is the common difference, N is the number of terms, Tn, nth term, any particular term. That means T10 means 10th term, and so on. The first basic usage was this formula, that is the term formula. So let me write over here, this is the term formula. That means if I plug in the first term, the number of terms, and the common difference, I can obtain a formula. So that is like worked example 1, getting the 7th term. And the next thing, that is a particular term is given, and I can find how many terms are there in order to reach this. So both are using the term formula. Then some other sequences, a sequence of square numbers. This is 1 square, 2 square, 3 square, 4 square. So basically this is n square. To these square numbers, if I add 1, so 1 becomes 2, 4 becomes 5, 9 becomes 10, 16 becomes 17. So now the sequence is n square plus 1. Square numbers and add n, the number itself, the position of the term itself. T1, this is 1 square plus 1. T2, 2 square plus 2. T3, 3 square plus 3, and so on. Some most examples of square numbers, first add 1, then square. N plus 1 whole square, 1 plus 1 whole square, 2 plus 1 whole square, and so on. So basically, T1 is the square of 2. It's not the square of 1, it's the square of 2. T2 is the square of 3. Similarly, first subtract 1 and then square. Subtract 1 and then square. More examples. Now, these are cube numbers. 1 cube, 2 cube, 3 cube, that is n cube. Cube numbers, subtract 1. 1 minus 1 is 0, 8 minus 1 is 7, 27 minus 1 is 26, n cube minus 1. Square plus cube, n square plus n cube, 1 square plus 1 cube, 2 square plus 2 cube, 3 square plus 3 cube, and so on. Then we dealt with a fraction in which the numerator was following a linear sequence. An arithmetic sequence is a linear sequence. The denominator was following a square number. So basically, this is n over n square. I can write it like this. Quadratic sequence. What is a quadratic sequence? The second difference is constant. So we wrote this thing, Tn is n square plus n plus 1, and then we plugged in different values of n. So 1 is 1 square, 2 is 2 square, 3 is 3 square, plus n, plus 1, plus 2, plus 3, and this one is a constant. So these are the different numbers that we get. When we do the observation, the first difference is an arithmetic sequence. That means the second difference is constant. That means if the second difference is constant, this is known as a quadratic sequence. More examples on quadratic sequence. 2n square plus 3n plus 1. Again, we obtain these 6, 15, 28, 45, 66. The first difference is an AP arithmetic progression, arithmetic sequence. Let me write it over here, arithmetic sequence. I can sometimes use the word progression, sometimes series, sometimes sequence. For our purposes, they all mean the same thing. And then the second difference is constant. Therefore, it's a quadratic sequence. So now we will be doing some past paper questions. Let me pause the recording for Azan. So now let's continue. So lecture number 2 of algebra, we are starting with sequences. And this time we are looking at past paper questions. Now, the first thing, it says the sequence of numbers. Let me highlight those numbers. The sequence of numbers 1, 5, 11, 19, 29 can also be expressed in this form. 1 square, 2 square, 3 square, 4 square, and these values that are added over here. So let me break it up into two. This is 1 square, 2 square, 3 square, 4 square, square numbers. And then in 1, 0 is added. In the case of 2, 1 is added. In the case of 3, 2 is added. In the case of 4, 3 is added. A number lesser. Now, first of all, we are interested in two dots, the blue and the green. As far as the blue is concerned, the fifth term, that will be 5 square. And there is a positive sign. And for 5, 4 will be added. So express the fifth term in the same format. That thing is done. Write down in terms of n a formula for the nth term. So if we talk about this, so over here, if we talk about, let me use the blue color. So this is T1 is 1 square, this is 2 square, this is 3 square, this is 4 square, this is 5 square. So therefore, Tn, the blue dot, let me use the blue dot over here. That will be what? That will be n square. Got the idea? And when we talk about the green dot, so that green dot is 1 lesser. So in T1, this is 0. In T2, this is 1. In T3, this is 2. In T4, this is 3. In T5, this is 4. In Tn, this is n minus 1. So that is how you get this thing. Write down in terms of n a formula for the nth term. It's by observation that you learn this. Calculate the value of the 100th term of the sequence. So the value of the 100th term of the sequence will be dependent on this. So therefore, Tn is n square plus n minus 1. Therefore, T100 should be 100 square plus 100 minus 1. 100 square is 1, 1, 2, 3, 4 zeros, and 100 minus 1 is 99. Therefore, the answer is 10099. That is the answer for this particular part. That is how this particular question is done. So let me pause the recording so that you can copy and complete this question. It's completed. All you have to do is to copy it. So now this question is done. Let me move to the next one. Another past paper question. The question says the diagram shows the first 4 rows of a pattern of number. So the first row is this one. That is row number 1. That is 1, 2, 1. This is row number 1. And then we have row number 2, which is 2, 3, 2, 3, and so on. 2, 3, 2, 3. It like kind of alternates. Row number 3. That is 3, 4, 3, 4, 3, 4, 3. And of course, it will also alternate. The fourth row, that is 4, 5, 4, 5, 4, 5, 4, 5, 4. So now the numbers are increasing in this manner. Now it says the table shows some results obtained from this pattern. Now these were samples. This is like 1, 2, 1, starting with 1. So 1, increase 1, decrease 1. Starting with 2, increase 1, decrease 1. Starting with 3, increase 1, decrease 1. Starting with 4, increase 1, and then decrease 1. Row number 1, 2, 3, 4, 5. this is in. Row number of numbers in the row. Row 1 has 3, row 2 has 5, row 3 has 7, 9, P, and this is denoted by X. So now the numbers are increasing by 2. So very simply, I can write over here that P comes out to be 11. That's a simple thing that I have written. Product of the first two numbers in the row. So product of first two numbers in the row, that's over here. 1 into 2 is 2, 2 into 3 is 6, 3 into 4 is 12, 4 into 5 is 20. And that's row number 4 over here, product. That's right over here, 20. That means for row number 5, let me write it myself. So row number 5, that would be 5, 6, 5, 6, 5, 6, 5, 6, 5, 6, 5. That's how it will go. So that is row number 5. Let me just highlight this. So this is row number 5. 5, 6, 5, 6, 5, 6, 5, 6, 5, 6, 5. Two more. That is the pattern. And over here, the product is 5 and 6, that is 30. And over here, the product, this thing was P. So that was P. Let me highlight it. The value of P was 11. So Q is 30, P is 11. Sum of all the numbers in the row. Okay. So now added manually for right now. 1 plus 2 plus 1. That is 4. And this is 12. There is a difference of 8. There is a difference of 12. There is a difference of 16. So basically, this is 8, this is 12, this is 16. The difference is increasing by 4. So the next difference should be 20. So 40 plus 20, that is 60. So let me write over here, that is 60. And let me also highlight this. This thing is done. And then say it says middle number in the row. So for two of them, the middle number is 2. And for these, the middle number is 4. And coincidentally, the middle number is 4. And 1, 2, 3, 4, 5, the middle number is 6. So the middle number is 6. That's right over here. And this thing is also done. So I have obtained the value of P, Q, R, and S. That is 11, 30, 60, and S. S is 6. Now the first part is done. Find expressions in terms of N for X, Y, and Z. So now we are looking for expression in terms of N for X, for Y, for Z. Okay, so now basically this is a linear expression, an arithmetic sequence. There is a difference of 2. So let me first evaluate X. So let me focus on X, number of numbers in the row. So part B, if I focus on X, that should be derived from 3, 5, 7, 9, 11. 3, 5, 7, 9, 11. This is an arithmetic sequence. Now, if it's an arithmetic sequence, I have the formula Tn is A plus N minus 1 into D. A is 3. And D is second minus the first term. D is 2. Because an addition of 2 is taking place. So let me write over here Tn is 3 plus N minus 1 into 2. That is 3 plus 2N minus 2. So 3 minus 2 is 1. Therefore, this is 2N plus 1. So basically, X is 2N plus 1. So right over here, X is 2N plus 1. That's the first thing that's done. Now the next thing, that is product of the first two numbers. How can I get this? Product of the first two numbers, this is 2. This is 6. 2 into 3 is 6. 6 into 2 is 12. 12 into this thing. No, it's not working out. This is product of first two numbers. Now, the first number is what? The first number is this thing. The second is this. That's 2 into 3, 3 into 4. So basically, this is n and this is n plus 1. I think that is the observation. This is n and this is 1 bigger. So if I talk about y, so I'll write y is n plus 1. That is by sheer observation. So y is n plus 1. That thing is done. What else is there? What about z? If I focus on z, 2 becomes 4, 6 becomes 12, 12 becomes 24, 20 becomes 40. So basically z is 2y, but z is 2 times n plus 1. That is what z is. So now I hope it's all good, all clear. Now it's asking part C, write down the middle number in row 101. Middle number in row 101. So z n is 2n plus 1. If we are looking for Z101, that is 2 times 101 into 101 plus 1. Just use a calculator and then you will get this particular answer. So that's how this particular question is done. So now with each new question, you will be learning something new. So let me just highlight this. This is summer 97 question. This is summer 2009. And that is just an extension of that. Now, this particular one, which is question number 46. Let me pause the recording and let's see if you can try it out. Then I'll give you the solution. So now let's look at this question. The question says U subscript n, just like T subscript n. That is the nth term of the sequence 4, 7, 10, and 13. Part 1, A part 1, write down an expression in terms of n for un. Now, the very first thing that you need to check is that whether it's an arithmetic sequence or not. In most cases, it is. And if it's not arithmetic, it would be something with square numbers or quadratic that we will soon see. So 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13. Yes, it is arithmetic. That's the first thing. All you have to do is to write down the value of a, which is the first term, which is 4, and the common difference, which is positive 3, because the numbers are increasing. And then write the formula Tn is a plus n minus 1 into d. That is 4 plus n minus 1 into 3. It will be in terms of n. That is 4 plus 3n minus 3. This is 3n plus 1. That is Tn, or you can write this thing as U subscript n. The first part is done. And then the second part, write down, hence find the 20th term of the sequence. So 20th term of the sequence is 3 into 20 plus 1. You replace n with 20. That's it. 60 plus 1, that is 61. So this thing is also done. That is the first thing that needs to be done. Now, it's a good practice for you that the next part, part B, that is also seems like another arithmetic sequence. Let's have a look. So that is my gut feeling. I need to check it. Part B. There is 15, there is 13, there is 11, there is 9, and so on. Now, what is being added? We are adding. Yes, we will use the term add rather than subtract. So we will use this thing, and it's about adding a negative value. So we are adding, this is plus sign and then negative 2. And then we are adding a negative 2 and a negative 2. That means the first term is 15. The common difference is negative 2. And again, the first part, write down an expression in terms of n for Vn. So Tn or Vn, just to differentiate between the two, they use Un and Vn. The original terminology is Tn. So Tn is a plus n minus 1 into d. That is 15 plus n minus 1 into, the common difference is not 12, that's negative 2 into negative 2. So that is 15 plus actually minus 2n plus 2. 15 plus 2 is 17. That is 17 minus 2n. That is tn or vn. So this is B part 1. That is done. Now it says a wn is nth term of another sequence that is obtained by multiplying un by vn. Given that wn is this, find k. So now we have un, that is this one at this thing over here, that is 3n plus 1. And then we have vn, which is 17 minus 2n. And they are saying wn is un into vn. Just multiply the two. So that is 3n plus 1 into 17 minus 2n. That is 3n into 17. That is 51n. That is negative 6n squared. That is positive 17. And that is negative 2n. So 51 minus 2, that's becoming 49n minus 6n squared plus 17. In which order have they written? They have written the constant first, 17, and then kn minus 6n squared. So that is 17 plus kn minus 6n squared. So 17 is over here, 17 is over here, minus 6n squared is over here, kn is like 49n. Therefore, what's the value of k? The value of k is 49, and that is the answer that we are looking for. So find k. K is the coefficient of n, and that is this thing. Now, let me just double check one thing. That is this. That have I done all the multiplication correctly? 3n into 17, that is 51. 3n into negative 2n squared. 1 into 17, that is 17. 1 into negative 2n is negative 2n. That is all good, all clear. And this one, this is 17 minus 2n. That is good. And that is 3n plus 1. And that's how this question is done. So I hope everyone who's watching this thing, once they have tried it out, and that is what you have to do. It's being taught in a live class, and once you see it on YouTube in my channel, so you have to stop it over there, first try it out, and then double check the answer. So all good, all clear. Now the next one. I would again like you to try this particular question out. So now let's try out this last question for this particular video. It says the first 4 lines of a pattern of numbers are as shown below. Our first line, 3 square minus 1 square. Now this first line, there is a 1 square. That is what I'm focusing on. Second line, this is 5 square minus 1 square. So basically this 1 square is a constant. So let me highlight this. This 1 square is a constant. And then for first line, there is 3 square. For second line, there is 5 square. For third line, there is 7 square. For fourth line, there is 9 square. So these numbers, they are actually increasing by 2. So that is an arithmetic progression. So first of all, I need to write down an expression in terms of n to complete the nth line of the pattern. So for that, I'll be needing this particular pattern. So let me mark over here, part B. And for part A, that is just a pattern. So T5, the fifth line, let me write all the lines. Fifth line, that would be 9, and this would be 11 square minus 1 square. For the sixth line, add 2 of it, 13 square minus 1 square. For the seventh line, that should be 15 square minus 1 square. And then if I write it further on, this green thing, that's 8 into 1. That's 8 into 1 plus 2. That's 8 into 1 plus 2 plus 3. That's 8 into 1 plus 2 plus 3 plus 4. So therefore, over here, we will write this is 8 into 1 plus 2 plus 3 plus 4 plus 5, because there are 5 lines. And this is 8, 1 plus 2 plus 3 plus 4 plus 5 plus 6. And then over here, 8, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. That is what is happening over here. Now it says that write down an expression in terms of n. So first part is done, part B. So I'm focusing on 3, 5, 7, 9. So T1 and then T2. So let me just write 3, 5, 7, 9, and so on. So Tn, it's an arithmetic sequence. That is A plus n minus 1 into D. And what is A? That is 3. What is being added? Plus 2. So therefore, Tn is A plus n minus 1 into 2. That is 3 plus 2n minus 2. So 3 minus 2 is 1, 2n plus 1. That means the nth line expression. So the nth line expression is basically 2n plus 1. It is being squared. There is a squaring over here. So what I found was on the inside. And then what is being subtracted? Minus 1 square, which can simply be written as 1. So we can write it out like this. And does it ask us to expand it? No. Using the nth line of the pattern, show that 1 plus 2 plus 3 plus 4 all the way till n is this thing. Now this, let me just expand it a bit more. So therefore, this is 2n, the whole thing square. That is 4n square plus 4n plus 1 minus 1. That is 4n square plus 4n. That can be written as 4 common, n plus 1. Now, this is the nth line written in this format. But at the same time, we know that this is also equals to this. So therefore, the nth line also equals to 8 multiplying with 1 plus 2 plus 3 plus 4 plus all the way till n, because that's the pattern over here. Have a look. For the first line, it's 8 times 1. For the second line, it's 8 times 1 plus 2. For the second line, it's still 2. For the third line, it's still 3. For the fourth line, it's still 4. For the fifth line, it's still 5. For the sixth line, it's still 6. For the seventh line, it's still 7. So for the nth line, it should be till n. So now these two, this nth line and this nth line, the blue and the purple should be the same. So let me write it out. 4n bracket n plus 1, the simplified form equals to 8 into 1 plus 2 plus 3 plus 4 dot 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 all the way till n. They're asking us to make this the subject. So let me just use an eraser over here. They're asking us to make this the subject. So therefore, 1 plus 2 plus 3 plus 4 plus n should equal to n plus 1 over 2. n plus 1 over 2. If I equate it, what happens is that let's divide both sides by 8. When I divide both sides by 8, this is n plus 1 over 2. This is 1 plus 2 plus 3 plus 4 dot 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 all the way till n. And hence I have proven it. QED. That's quite easily done. So that is how this particular part is done. And that is for being happy that we have done it all good, all correct. And that is end of lecture number 2 of sequences. So this is algebra lecture number 25. And as far as sequences are concerned, this is lecture number 2. Stay tuned for more. See you in the next class.